Can you hear me okay? I assume so. So today I'm here to talk about this very lofty title called Platform Engineering, the backbone of the next evolution in cloud native with CAPI and Rancher. We'll talk a little bit about whether or not my talk is actually going to be about this. But first thing first, who am I? Before we dive in, a quick disclaimer. I am not technical, which means I've never coded, apart from C++ in high school for a couple of years. So I kind of need to lower your expectations for my talk. There's not going to be a live technical demo. I'm not going to magically fix your worst configuration nightmares. And I'm here to share my views on platform engineering and how it influences the way that I think about the products that I'm managing, which I've been doing since September 2024. Primarily K3s, K2 are most popular Kubernetes distributions, as well as Rancher and CAPI, the cluster API within it. So that's kind of that. And since I don't really have street cred when it comes to the technical, here's why I believe I can talk to these topics. I've worked for some pretty interesting companies in the past, and I've worked with some incredibly smart people who I've learned a lot from. And they've influenced my thinking and how I think about serving people like developers and platform operators and platform engineering teams going forward. So let's dive straight in, right? Imagine you're managing thousands of Kubernetes clusters across hybrid clouds, edge environments, and on-prem and data centers. How do you kind of maintain consistency, scalability, and agility? The answer is in platform engineering. I'm sure most of you have seen these Gartner reports and the stats. First off, what is platform engineering? It's a discipline that builds and maintains platforms to simplify infrastructure management for developers and operators and provide self-service experiences to accelerate the path to production. This is all about time to market, really. It's all about accelerating developer productivity. It's all about reducing the operational overhead and costs that come with developing code in large organizations. It enables organizations to scale efficiently across distributed systems. And that's why in 2023, Gartner predicted that 80% of software engineering organizations will establish platform teams as internal providers of reusable services, components, and tools for application delivery. So kind of the path of consuming goes upwards, right? So why am I talking about this now? That's because as I was researching this and prepping for this talk, I realized that the knowledge I had about it was about a year and a half outdated. It was what I would call BC, before child. And so I started kind of updating and researching what was happening in the market. And boy, I was not disappointed. The sentiment had changed somewhat. I went through articles, talking about how platform engineering journeys can derail some of the challenges that people were kind of encountering. Developers just didn't want to work a certain way that they were being set up to work in because they expressed frustration that the mental capacity required to both build their product quickly and to also reshape how they did development was too time-consuming. The cognitive load was just too high. And so you can build a brand new platform, but it does require leadership to understand that devs will need time to adapt their code bases around it. And so to summarize all of this, I kind of came away thinking, well, done well, it seems like there is, where's my cursor here? Is it down, left? Here. Done well, it seems, platform engineering can be a massive shift towards self-service and paved paths and developer experience that is massively improved. Done fine, it's just an evolution of DevOps or DevSecOps. Done poorly, it turns into a bit of an admin role. So I wanted to kind of briefly chat about this bit here. Mark O'Neill saying, is platform engineering falling into the trough of disillusionment? Yes. Who's familiar with the hype cycle for software engineering or with the hype cycle that Gartner espouses? Yeah? Okay. So basically, for those of you unfamiliar with it, it's a graphical representation of adoption, maturity, and social applications of various different technologies that was and is developed by Gartner, and so they bring it out with every single report that they make on the industry. And so for platform engineering, this is kind of where they say we are. We're at the peak of inflated expectations, and we're about to enter the trough of disillusionment. And so I wanted to chat about why that is. The peak of inflated expectations, how did we get there? So there's kind of the sentiment that the industry is at the pivotal moment when it comes to platform engineering. The shift is critical in bridging the gap between development and operations. But organizations must continue to invest in it and invest into robust self-service platforms to remain competitive. There's also belief that platform engineering is important because it isn't just yet another IT function. I know Nelson said we're all IT, but it isn't just another IT function, right? It's a strategic backbone for innovation because it delivers at the top end, it delivers features and business value, right? And then there's obviously kind of some of the challenges around how do you align yourself with business goals, right? How do fragmented tools and processes hinder true platform efficiency? And so how kind of did we get into the trough of disillusionment? What are some of those challenges? And it's actually not surprising to hear this, right? Multi-cluster environments in hybrid or multi-cloud setups are difficult and challenging to maintain, right? The consistency of configurations and updates across those, the complexity is just sheer and vast. There's also a significant need to balance developer needs and operational realities, right? A developer often wants speed and simplicity, right? Onzi once said, here's my code, run it in the cloud, I do not care how, to represent kind of the developer needs. But as kind of those need to be balanced with operational realities, right? Around security, control, role-based authentications, compliance, etc. And so there's real friction between kind of those two constituencies, as well as some real-life problems that you encounter. Manual processes for cluster lifecycle management, difficulty managing Kubernetes upgrades and rollouts at scale, as well as addressing security, performance, and availability across diverse environments. It's not surprising that people think that we're entering that trough. Those are difficult problems to solve. And I do believe that without robust platform engineering, we still continue risking being stuck with fragmented and inefficient systems. So how does platform engineering actually attempt to address those challenges? It's through self-service abstractions. Automated cluster provisioning, self-service namespaces, right? Providing easy and consistent access to infrastructure for developers. We're talking about standardization, right? What are some of the consistent practices that reduce errors and simplify operations as organizations scale? And then reliability and governance, right? You're ensuring security, compliance. You want to give developers what they need to get the job done, not what they want. That is a very important distinction. And you want to kind of bridge the gap. You want to align with the rapid pace of development with the required necessary operational controls. So what do I believe we could do to avoid that trough altogether, right? And maybe enter the slope of enlightenment a little bit sooner? I'm a big believer in platform as a product. It's a bit of a mind shift. You're not just developing a platform and shipping it, but rather you're thinking about your developers as your users and as your consumers. So really anything as a self-service. You want to remove any roadblocks that developers may face so that they can go on faster and forever do that. You want to codify and share organizational policies to decrease risks by automating manual processes and reusable components. You want to increase that efficiency by managing and scaling and kind of treating them as a fleet. And so the last thing that I think is missing, and most importantly, is applying product management practice. I'm a product manager. You won't be surprised for me to say this. I believe that there's two feedback loops that are currently missing when we talk about platform engineering. The first one I've highlighted there in the middle. It's between platform engineering teams and developers, so really the product and engineering teams that ultimately develop capabilities and features that result in business value, whether those be internal, right, whether it's your current Salesforce setup or whether it's a banking application that is at the top. That is the feedback loop that needs to be created, right? And the second one is between that business value and the platform engineering teams. So tying it back to the business value that you're delivering and treating your developers as users and customers. So that would be kind of my my big thing. And I have to give a plug here for the lean startup. Everybody who works in Agile has seen this, but also the first people who actually advocated for bringing product management practice into the platform engineering space were ThoughtWorks in 2017. So this isn't new thinking, and it's been evolving ever since. If you read team topologies, etc., you'll get a lot of value out of that if this is an area of interest for you. So why do I care so much? I've talked a lot. You can probably tell I'm quite passionate about it. But it's simply because I work on two areas that are directly related to platform engineering and developing capabilities for those teams. The entry point to Kubernetes is not easy. It can be quite complex. Managing distributed systems is hard. And very frankly, as a product manager, I want to make that as easy, or at least as abstracted as I possibly can. Nelson calls it ClickOps, but I think of it as abstraction layers. And I want to do so without kind of pushing customers or adopters into vendor lock-in. And that is kind of the entire SUSE philosophy around providing choice in our open source credo. So for those of you in the room, could you raise your hand if you've heard of Rancher? Everybody, love it. Who has actually used Rancher? Amazing, great. Who has heard of CAPI? Cluster API. Cluster API. Ooh, okay, this is interesting. All right. So I'll give a quick spiel, and you can tell me, because we're already kind of, how much time do I have? Good time. Okay, we can go as deep into any of these areas, but essentially, what is CAPI? CAPI, the Cluster API, is an upstream Kubernetes project that provides declarative APIs for cluster lifecycle management. It focuses on infrastructure as code for Kubernetes clusters, and some of the core features are cluster class, a templating mechanism really that defines consistent cluster topologies, but also enables declarative upgrades and has massive provider flexibility because it basically supports multiple cloud and on-prem infrastructure. So AWS, Azure, vSphere, whatever, they probably have it. And then with Rancher, this is another piece that I'm currently responsible for, right? It's a unified interface for managing clusters across environments. You have the governance baked in, etc. And we make provisioning as simplified as we possibly could and allow you to manage clusters in a centralized way. And so for those of you who are not familiar with CAPI, I'll just briefly go into the topics. And remember, I'm not technical. I'll try to get this right in translating it for you. But it's an interesting one, and because it's an open source project, I'll also talk about how we integrate it into Rancher a little bit. But all right, snowflake problem. I'm sure you've heard this before, but the snowflake problem refers to when every Kubernetes cluster is unique, right? You all just want a Kubernetes cluster. You just want a simple Kubernetes cluster. But once you kind of bake in the networking and all of the other bits that you need, its uniqueness makes it really difficult to standardize the process across those different clusters. And so when those clusters are kind of individually customized, it's harder to automate tests, it's harder to upgrade, monitor, troubleshoot, you name it, it kind of hinders the scalability of managing many clusters at once. So what is CAPI? As I mentioned, CAPI has originated within the Kubernetes community. It's since then evolved quite significantly. The last time I touched CAPI was probably 6 or 7 years ago when I was still at Pivotal. And it's since then evolved to become quite a robust way kind of with declarative API frameworks that enables some of that management of cluster provisioning that is a little bit more consistent, etc. Its purpose is entirely to provide a declarative approach to managing clusters and the lifecycle of those. This means you basically define the desired state of your cluster in a configuration file, and CAPI's controllers work to ensure that the current state matches the desired state. And there's standardization across providers. So it abstracts the underlying infrastructure details. So it enables you to kind of use a common set of operations, whether you're deploying on cloud providers, on premises, or at the edge. And that makes it easier to manage clusters consistently across different environments. Some of the benefits I'll just whiz through in the interest of time is simplified cluster lifecycle management. It automates key processes such as provisioning, scaling, upgrading, etc. Because it uses a declarative approach, that kind of helps. You also have unified operations, so it means that the standardized API works across multiple cloud providers and on-premise infrastructures, so you don't need to learn provider-specific tech, essentially. And it provides you with flexibility. There's abstraction layers, which means you can change the underlying infrastructure without changing the management process of those clusters, which is quite impactful. And there's kind of other pieces like automated scaling, self-healing capabilities that kind of enable you to continue scaling and improving your resiliency. And obviously, because it is an open source project, there's a huge community around it and an ecosystem that's kind of being built out. So it's quite great. One piece that is worth talking about when it comes to CAPI is the CAPI providers. This is a core concept within the cluster API. You have infrastructure providers way over there. They are responsible for creating the underlying resources that are needed to provision a Kubernetes cluster. So whether you're deploying on public clouds like AWS, GCP, or Azure, or kind of on-prem, like vSphere, those infrastructure providers will abstract the details of those environments. So you don't need to worry about that. They handle the provisioning of compute, networking, and storage resources, and you don't have to worry about those, which is fantastic. And then the next one up, you have the bootstrap providers. So they are really responsible for turning a raw machine into a working Kubernetes node. So this means installing the relevant and necessary software, configuring settings, ensuring that the machine is ready to join the cluster. So the way that I think of them is as the kind of setup crew, right, that prepares each node to be part of a Kubernetes cluster. And then you have the control plane providers. They're basically the heart, the beating heart of your Kubernetes cluster. It orchestrates everything from scheduling, managing the overall state of the cluster, etc. They also ensure that any critical component is set up correctly and is running reliably. So these are just really, really incredible. And it's really powerful because this modular approach simplifies the process of cluster management, but it also allows you to mix and match some of these components that best fit your operational needs. So there's quite a lot of power in CAPI, but the learning curve can be quite steep. There's a bit more that I could go into, but I'll jump straight ahead. Well, maybe this one. Some of the kind of operations that you can perform, creating clusters, scaling, upgrading, and deleting them, the usual stuff that you would expect to kind of do. And so how do we integrate it with Rancher? We've built a Kubernetes operator that provides integration between Rancher Manager with Cluster API. It runs directly on the Rancher Manager cluster, which means it does have a Rancher dependency, but our goal ultimately is to make this the best off-the-shelf CAPI implementation you can find in the market, because we found that it is the preferred tool for developing and managing, that Rancher is the preferred tool for developing and managing CAPI infrastructure so far, and we want to continue on that journey. What's this? What can you do today with our cluster API? You can manage the lifecycle of downstream Kubernetes clusters using Rancher. You can deploy clusters using Fleet. That is one of our fleet management options, as the name suggests. You can import CAPI clusters into Rancher so that you can then use Rancher to connect to it. You can use CAPI-specific features like cluster class, which is really powerful, as well as manage the cluster API and provider versions. And yeah, it's not provided out of the box. It's installed as a separate application, but that really isn't a big one to kind of work through. Cluster class, just briefly to touch on this because I'm a big fan and I look forward to kind of working more on this with the team. Cluster classes and cluster templates are similar but have powerful differentiation. Cluster classes define reusable declarative blueprints for clusters, specifying infrastructure, networking, and add-on configurations. They enable consistency and standardization across multiple clusters. So you create it once and then you can kind of, get your cluster sorted. Whereas cluster templates are predefined configs or manifests used to initiate cluster with specific settings. And they're often customized per deployment. So cluster classes kind of enforce a structured approach for cluster creation, which is quite powerful when you think about managing clusters at scale. Whereas cluster templates provide a more flexible, but also ad hoc method for cluster provisioning. So those are some of the things that I'm working on, and you can see how the kind of platform engineering pieces are kind of influencing how we're thinking about implementing these different capabilities. So what's my call to action for this group of people as you're thinking about it? The future of cloud native is distributed, it is scalable, and it is automated. Platform engineering is key to making it manageable, and I believe that platform engineering still has the power to transform how organizations manage distributed systems. I really want to encourage everybody to embrace platform engineering to unlock innovation and operational excellence, but I also have a call to action for those of you who are developers in the room. Please advocate for your platforms that empower you to focus on coding, not necessarily infrastructure. For the operators in the room, leverage tools like CAPI and Rancher or others to automate some of that complexity away and scale seamlessly. And advocate in your organizations to continue investing in platform engineering teams and give them the time and space and ability to manage the platforms as products and treat their developers, as in their audience, as customers, and give them what they need to do their job, not what they necessarily want. So with that said, I'll soon be handing over to the more exciting part of the evening, which will be Fraser, and he will probably also have a demo for you. So what I couldn't deliver, he will. Thank you.
Do you want to take questions?
I can take questions, or you can corner me during drinks. That works too.
If you have any questions, please feel free.
Yeah.
Yes, I have a question with regards to CAPI. So you presented it, and I was first trying to see where it fits with other tools that I've been using in the past. Would it be the kubectl or Terraform infrastructure as code tools? The interface I see is an API. So does that mean that you have a CLI that which is Rancher that will be using? Do you have other CLIs that you integrated with?
Yeah.
Terraform and so forth to see how we would move on with Rancher?
You could almost say that you could replace Terraform with CAPI, very frankly. But we can talk about that a little bit. Yes, so getting started with CAPI is not trivial. It requires somewhere between 300 and 500 lines of YAML, which I don't think anybody gets excited about writing. So the learning curve is steep. So what we're trying to do is abstract it. So we do have a CLI that you can interact with, and we're also trying to build a GUI to make it more ClickOpsy, the way that kind of Rancher Manager originated, to provide some of those customer journeys in a very simple and effective way. So yes.
Okay, sorry. For CAPI, more like a setup tool for an environment, really.
You could, yeah. It makes it really simple and effective. Like this is what, if I had to manage clusters and I'm thinking about how do I manage all of these various different infrastructures that I have, CAPI solves quite a lot of that for me. I want to set up an environment. I want to give you, a cluster on that environment. CAPI is my go-to because it sorts the infrastructure out, because like Google has their own provider, CapG. vSphere has their own provider, CapV. You can use those, you bring them into CAPI, and you can use those to provision the infrastructure you need and everything on top. So it removes quite a lot of the cognitive load that would be required to actually set up a cluster in an environment and make it functional.
Cool. Okay.
Yeah.
Yeah. Okay. We'll hand over. Thank you very much.
Yeah. And just to plug, CAPI is an open source project. We have our own implementation through Turtles, bringing the integration into Rancher. It is an open source project, so you don't have to use Rancher, etc., to go and play with it. There is massive and good documentation on there as well. So just, wanted to